guys. Hello. Sorry I was late. I was having some tech problems. So,
Wait, Josh.
hey guys.
Do we need a calculator today?
Yeah, if you could bring a calculator and a pen, okay? Maybe you won't need a calculator. Depends on how I guess if you're mental math, but I think it's good to have a calculator. Make sure we're accurate. We don't make any mistakes. We have a kind of a cool thing we're gonna do today.
Yeah, I'm not sure if we own a calculator, honestly.
That's okay. You know what? You guys can also use your computer too. If you type in calculator, that'll work too.
There's a calculator.
These look young. Look a lot of younger.
All right, we'll give people some time to log on.
That was funny. Yeah, this is Ava. Like some crazy hard math. What did it say? Divide and trillions.
Okay.
Next to
Give people one more minute to log on and then we'll go ahead and we'll get started, okay? I have something, this was requested last week. So if you're here last week, I think you're gonna know what maybe today's topic is. But I think you'll like it. It's kind of fun. A little bit different. Let's see if we get any more people. All right. I'm gonna go ahead and kick it off, guys. So first off, thank you everybody for coming. I really appreciate it that you're all here and you're ready to learn something new about science today. So what we're actually gonna be focusing on is a topic we were talking about last week a little bit. We didn't really get too much into it, but today we're gonna dive a little bit deeper. So give me 1 second. Let me load up my presentation here, and we are gonna go ahead and get started. Oh, let's see. There we go. Cool. All right.
I'll get it up when we need it.
Let me do this. Let me share my screen. Okay. Sorry, I'm on a new computer, so things are kind of different. Let's see, where do I get my share screen? Here we go. Wonderful. All right. So today, guys, we're going to be talking about the science of numbers. Last week we were talking about some what's like the largest number in the world and what's the smallest number, and I thought it'd be kind of cool to look at this. And even though it's not your traditional science stuff, it's definitely in the STEM field, and I think that we could talk about it. So it'll be kind of fun. Let me admit somebody in the waiting room. Cool. So let's go ahead. Let's get started here. So if we take a look, what actually are numbers? Okay, maybe I'm sure you know what a number is, but maybe we need a little bit more of a real definition of a number. So a number is really any form of text, and that could be a word, that could be a little symbol. So here you have our words, here we have our little symbols. Any form of text that is used for counting. So I know you guys know about numbers because you've seen them before. I mean, of course, but I just want to start here, just kind of get a baseline so everyone knows we're on the same page what numbers are. Numbers are symbols or they are text like words that represent counting. And numbers, they could be added, subtracted, multiplied, divide. Okay, so this is pretty basic stuff. You guys know about that. Okay, oops, sorry, calendar popped up. Now, let's go a little bit deeper. Now, what are the different types of numbers? So numbers actually, it's not just the standard numbers you're thinking of, like 1, 2, 3, 4, 5. There's lots of different types of numbers that we count. And there's really the two big sets of numbers. And the first one is real numbers, and the second one is complex numbers. Okay, and I'm sure a lot of this is new for you guys, and you're gonna be learning a ton more about this as you get to high school, middle school, all that good stuff. So don't feel like you have to process all this information now. I just kind of want to introduce it to you. So real numbers are the numbers that we know. Okay, that's the easiest way to think about it. The only way to say that they're different from these complex numbers is that they're just the opposite of complex numbers. They're just numbers you know. There's lots of different types of real numbers. So we have irrational numbers, which that's something that kind of extends infinitely. Like you have 2.3451, blah, 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 or you have pi, 3.14, and it keeps going. Those are real numbers. We also have rational numbers. These are numbers that end. So we have 3.64, right? It's not extending forever and ever and ever. It kind of ends after that 4 digit. We have the integers, which I'm sure you guys are familiar with this, but integers are negatives and are positive numbers and 0. We have whole numbers, so that's 0 on, and then we have natural numbers, which is 1, 2, 3, 4, 5, 6. Okay. Now, what's the opposite of that? And you're probably like, there's different kinds of numbers. Well, there's something called complex numbers, and this is where things start to get really weird. So complex numbers are really just, they contain this variable that we call I, okay? And essentially I is an imaginary number, okay? I isn't real. I can't possibly happen. And the reason why is this, okay? I represents the square root of a -1. Does anyone know what's wrong with that? If I say that in all these complex numbers, you see I. If I represents the square root of -1, what's wrong with that? Who knows? Why can't I take the square root of -1? Any guesses? Just go for it.
Well, I don't think you can take a square root of a negative number.
That's exactly it. You are 100% right. We can't take the square root of a negative number, and here's why, guys. So the square root of 1 is 1. Why? Well, 1 times 1 is equal to 1. Now, the square root of 1 could also be -1, technically, because -1 times -1 is also equal to 1. So those negative times negative, it cancels out. So it would actually be okay. Now, down here, guys, this is where we start to have problems. Remember, the square root of something, that means that you multiply that number by itself and it produces a square number. But nothing will ever produce -1 that are the same, because 1 is not the same as -1. It just doesn't work out. So keep big picture here, guys, because this can kind of get messy, but I want you to know that imaginary numbers is when we're talking about I, okay? It really can't exist. You can't take the square root of -1, and we try to write these out as complex numbers, but it's just not going to work. You can't take square root of -1, so there's no way on earth to classify this. Okay, so we'll leave it there. Not a huge thing to know, but just remember that there's no imaginary numbers, which is kind of weird. So now let's talk a little bit about exponents, because this is what we use, guys, to get really big or really small numbers. It's all about the exponents. So when I say exponents, really exponents is this thing, this 2 here. And when I say 10 squared, okay, this is how we call it squared, but when you see that 2 up above, it's kind of like someone pushed it up. That's the exponent. And that's telling us how many times we're going to multiply 10 by itself. So if it's 10 squared, guys, we multiply 10 by 10. Why? We multiply 10 by 10. We do it twice here because we have a 2 up here. So if this were 10 to the 4th, you'd see 4 tens on this side. We're multiplying 10 by 10 by 10 by 10. So it's telling you how many times you're multiplying 10 by itself. So here we're multiplying 10. It's just going to be 10 times 10 because our exponent is 2. So this really, guys, helps give us those super large and super small numbers. If you imagine, guys, if we went all the way up to 10 to the 30th, it would be 10 times 10 times 10 times 10 times 10. It would go all the way for 30 tens, and that number would be ginormous. So that's kind of how the big numbers start to form. Okay, here's another one, guys. What are these number prefixes? It's a big word. So number prefixes, maybe you've heard people say something like, I have a gigabyte of memory on my hard drive, or that's a kilogram of meat, or that's a centimeter on a ruler. I'm sure you guys have heard those terms before, but did you ever think, guys, that those prefixes are actually the clues to unlocking important information about the numbers? Here's what I mean. So you said kilogram, right? We were talking about kilogram. So a kilo means 10 to the 3rd. Or 1,000. 10 to the 3rd is just 10 times 10 times 10, and 10 times 10 is 100, times 10 is 1,000. So 10 to the 3rd is 1,000, guys. So when someone says a kilogram, they mean 1,000 grams. Isn't that cool? So there's lots of cool conversions we can make using this chart, okay? Because 1 gram times 1,000 is equal to 1 kilogram. A kilogram is 1,000 grams. So these prefixes, that's what we call the beginning of the word, like centimeter or millimeter or decimeter. That's telling us, it's very important. It's telling us what part of the meter it is. So if you were to, so that was kilogram. What if I said, can I have a petagram? What would a petagram be? It would be 1 gram times 10 to the 15th. It would be 10 to the 15th grams. So that would be, what is this number? This is huge. This is 1 billion. This is like a trillion. Huge number here, guys, that we're getting if we had a petagram. It's a
Actually,
trillion
a
grams.
quadrillion.
Maybe I counted that wrong. See, look at how many zeros are. 1, 2, 3, 4. Yeah, a quadrillion. Okay, so they're like, when you see this table, you really got to look closely and find the zeros and figure out how many packs of zeros you have. But yeah, it would be a quadrillion. I'm sorry, I saw it. I missed one of the zero sets. So there you go. It's a quadrillion grams to make a teragram. So this is crazy stuff if you think about how big we're actually getting. Okay, so now here we go. What is the world's smallest number? So we're going to be kind of talking about two different ways that we can get the world's smallest number. So the first is on Earth. We are on Earth. We are humans. We use normal numbers, we aren't going into imaginary numbers or crazy things. So really the smallest number in the real world, guys, is 0. You can't get any smaller than 0. It is not going to work. Now you have negative. I'm sure you guys are like, oh, well, wait a minute. There's a negative integers, right? There's -1, -2, -3. Sure. But if I were actually counting pieces on a table, the smallest I can get is 0. I can't be going into negatives, right? If I had like cupcakes, I don't have -2 cupcakes. It just doesn't make any sense. So really the smallest number in real world terms would be 0. But now let's go a little bit deeper. When you're doing math stuff, you guys are probably like, well, wait, there's negative numbers too. Yes, negative numbers work for mathematical calculations, for concepts. That stuff works. But technically, real world counting, it can't go past 0. But the smallest number, if we were talking about maths and conceptually, like concepts, guys, would be negative infinity. And negative infinity is just you're extending down the number line to the left. So we're going down this way, where you see my cursor going, forever and forever and forever. So we're just keep getting more negative, negative, negative. And as you get more negative, guys, it's just approaching negative infinity. So you can keep going all the way till -1,000, -1 billion. You can keep going until you reach negative infinity. Okay. So it's just a concept. Really, we use that for calculation purposes. But if someone says, what is the world's smallest number? The world's smallest number is 0. We can't get any smaller than 0 on Earth, like in the world, like when we're talking about objects and counting. Okay.
Infinity is not actually a number.
Infinity? No, negative infinity, you're right. It's not a number. It's a concept, right? It's an idea that if we just keep going to the left of the number line, we'll eventually you can keep going as far as you want down that number line. And the idea is you're never going to run out of numbers. You can just keep going -1 billion, -1 billion. It just keeps on going negative, negative, negative until there's a number that we can't even count because it's so big negatively. So yeah, so negative infinity is not a number. It's just a concept that you just keep going until forever, and whoever has time to do that, right? So now here, kind of the largest number is the same, okay? The largest number, right? Realistically, guys, what is the largest possible earthly number? What is your answer? Anyone have an idea? What is the largest possible earthly number?
Actually, there's no answer to this.
Yeah, exactly.
Numbers go on forever.
Right. Just like we said, guys, that we go to negative infinity. In the other direction, we go to positive infinity and beyond. You just keep going until honestly, you just go to the end. Like there's nowhere else to go. So when we say what is the largest number, my answer on Earth is whatever you want it to be. Okay, because think about this. Let's say someone says the largest number is 1 million, and you say, I don't think so. The largest number is 1,000,001. And someone says the largest number is 1,000,002. And you could just keep adding and adding to that until you get to 1 billion or to 1 trillion or quadrillion. Like it just keeps going. So really the largest number is whatever you can say, whatever you can write out. That is the largest number. There really is no scientific way to say that the largest number stops here. It goes forever. Now, here's the deal, guys. There is, though, the largest number that we've recorded. Okay, so I'm saying, look, the largest number, it could go on to infinity. So we can get even bigger than this number. But the largest number that's on record is 10 to the Google, and it's called Googleplex. All right, so 10 to the Google is 10 to the 10 to the 100th. And remember what I said about exponents. So that's saying that this guy, this 10 right here where my cursor is, this multiplied 100 times, and then whatever that is, we multiply this 10 by that many times. So this number is ginormous, okay? It took a guy, this man over here, his name's Wolfgang Nietzsche. He's a professor at Stanford for physics. It took him sextillion book volumes to fully write this number. Imagine. Here is his number. Here's his book. Googleplex written out. He wrote out this number 1000000. He wrote it, guys. And it took him sextillion books. Okay, think about that. That is so many books. This number is huge. So it took him like a year to do this, guys. So if anyone else, people could try to get a little bit bigger than that, but it's just a matter of how much time you have, right? We can keep going and get bigger numbers, but it's a matter of how much time we have. And it's also a matter of this committee over here. You see these people on the right, these like official looking people? Okay, this is called the International Committee for Weights and Measures. And these are the people that really say, you know what, this is a number that we're going to name 1 billion. Or this is a number we're going to name 1 trillion. They're the ones that are doing the naming of numbers. So it's not so much a matter of how big of a number we can get, but it's a matter of, do we have a name for it, right? You can write out some ginormous number, but if you don't have a name for it, what would you call it? It's all has to do with naming. That's why you guys know Google or Googleplex. You know those because they have names. So names are critically important, okay? So really, the largest number that they have right now is 10 to the 24th power. That's the largest they've recognized. So they haven't even recognized this professor over here, his huge number, right? Even though it's Googleplex and he named it that, they technically haven't really recognized it as a prefix. So they're still on 10 to the 24th. So the next number that they would be picking would be 10 to the 27th. But here's the problem, guys. Let's say this awesome professor, this Professor Nietzsche over here, he writes out his huge number, he's all set, and let's say that another professor decides to write out a huge number. Well, they have to wait. This committee only meets every 4 years. So numbers can only change about every 4 years officially. So the next number that we could get that's a little bit bigger than what they have named would be 10 to the 27th. So it's all a matter of really naming numbers. It's not a matter of how big we get. It's just a matter of, do we have a name for it? And has someone really actually written it out? Because you can dream up a number, but really this professor over here was the first one to actually like write out the world's largest number. And it took him a very long time to do. So it's all a matter of how much time you have. And if you guys see this, you see this spiral over here? That's the volume of the book he's on. Because he had so many books he had to write just to write out this number. He needed so much paper and so many different books that this is like the volume of the book. It's crazy project. So, all right, guys. So here we go. I want to give you guys a little something to think about. Can you think of a number larger than Googleplex, right? That's the largest number that we have written out. And if so, what would it be and what would you name it? Maybe you can think of the next name for the next largest number after Googleplex. I'd love to hear it. I don't encourage you guys to write out that number because it would take you so long.
What about the Busy Beaver?
The Busy Beaver? If you want to call it the Busy Beaver, you go for it. Look, any name you want, you can go. They have Googleplex. You can keep going a little bit higher.
That's actually one of the biggest numbers.
Yeah.
Googleplex.
Googleplex. So if anyone says, what's the world's largest number, you can tell them the largest recorded number is Googleplex. It could get bigger if people come up with something bigger, but where we're at is Googleplex. And to that point, someone said, well, what if I made a number bigger than Googleplex? I would name it the Beaver, whatever thing. It would probably be some format of Google. And the reason is because Google is kind of like our standard that we're using now to call these super large numbers. It's a good prefix to use. So you'd probably be using some form of Google. It might be Google, Flex or Google, Trex, or it could just keep going until you get some name for it. So it's kind of a weird, numbers, people think it's like so straightforward, and it's really not. When we get to these big numbers, it's kind of a matter of who had an idea and who wrote it out and who recognized it. That's really all it comes down to. So now, guys, so for today, I know we usually do some kind of a science experiment, but I want to do something different because this is numbers. There's not really I can't drop a cup of water or do some sort of elephant toothpaste or something crazy today because there's nothing really to do with numbers, but there are number magic tricks. And maybe you guys have done these before, but they're really fun. It's a good way to practice math, but it's also a good way to see, try out working with big numbers. So we're going to go ahead and do some number magic tricks today. All right. So I'm actually going to stay on this presentation, but what I want you to do, guys, is if you could take out, if you have it near you, if you don't, that's okay, no problem. But I want you to take out a piece of paper a pencil, and a calculator if you have that.
There we go.
Let me know when you're ready. Say, I'm ready.
I'm ready.
Ready.
Yeah, you're ready. Okay. So the trick we're going to do today is called Guess Your Friend's Birthday. So this magic trick, guys, all with numbers. If you do this, you will correctly guess your friend's birthday, the month and the day, which is really cool. Okay. So you can go up to somebody and guess their birthday. You're like a mind reader. It's like a cool math magic trick. That's why numbers are cool. There's so much stuff that you can do with them to get like these cool results. So here's the first step, guys. So the first step in this process would be to multiply, you're asking them to do this. So what you're going to do is you would sit down with your friend and you'd ask them, well, we're going to do a practice when we're done with this. I'm just going to go through the process with you. So what you do is you say, okay, I'm going to ask you to multiply the month you were born by 5. So you ask your friend, you say, think of the month you're born. Don't tell me, right? Because you're trying to guess this. So you're not saying, you're the magician. You're not going to be like, tell me the answer. You're trying to guess this. So you're going to say, okay, I want you to think of the month you were born and multiply it by 5. So if you're born in January, it would be 1. If you're born in February, 2, March, 3, April 4, May 5, June 6, yada, yada, yada. I'm sure you guys probably know this already, but those are kind of the ways that we number our months. So you assign your month that you were born. If you were born in January, you'd be 1, and you multiply that by 5. So let's pretend I was born January. I'm gonna give you a date here. Let's pretend I was born January 18th. All right, we're gonna do this for just a demo. So I'm born January 18th and you're the magician. So what I'm going to do is I'm going to think of January and I'm going to multiply it by 5. So right now I'm at the number 5. So now the next step is I would add 6 to that. Remember, you're the magician, I'm your subject. Now I'm going to add 6 to that number. So what's 5 plus 6? What's 5 plus 6?
This is 11.
11, right. So now I'm at 11.
I'm at 36 because I was born in June.
Oh, you're born in June. Okay, so there you go. So there's different, you'd be 6 times 6, 36. That would work. Now what I'm going to do, guys, is remember, you're the magician, I'm the subject. Now you say, Ava, I want you to multiply that number by 4. So my number was 11. What's 11 times 4?
11 times 4. Wait, okay, I'll see. So,
Yeah, let me know.
so
It's 44.
1,
44, cool. So now I'm at 44. Let's go to the next part. Now you say, Ava, add 9. So now I'm going to add 9 to that number. So what's 44 plus 9? Anyone guess? 44 plus 9.
53.
What is it, 53?
Yes.
153.
Oh, not 153. We're not that big yet. 53. Correct. All right. So now we're at 53.
That's
Now I'm going to multiply
I
this. This is
chose
going to be a big
that.
number. 53 times 5. You say, Ava, multiply your number by 5. So I do 53 times 5. What's that?
265.
265. Okay. And now I'm going to add the day I was born. So remember, I told you guys I was born January 18th. So now I'm going to add 18 to that. So I'm going to do 265 plus 18. What's 265 plus 18?
For my birthday is simple. It's just 1.
Oh, that's pretty nice and easy then. That's awesome. You're probably have a easy number for calculating. What's 265 plus 18? Who got that?
283.
283. Okay. So now we're at 283. And now you'd say, okay, you know, Ava, you're the magicians, guys. I'm your subject. And now you say, Ava, tell us what the number is. So I say, you know what? It's 283. That's the magic number that I have. What are you going to do with it? So now as the magician, guys, you're going to subtract 165. So 283 minus 165. What's that? Anyone get it?
3648480.
That sounds close, but I think a little bit off. Did anyone else get 118? 118?
Got it.
Yeah, you got that? Okay. So now, remember, you're the magician. You guys all got 118. So when was I born? Okay. So the first 2 digits are going to be the month I was born, and the second 2 are the year. Now look at this, guys. If you only have 3 digits, which that's us, we have 118. That's 3 digits. Then the first digit, we're going to put it as a 0. So can you guys put a 0 before the 118?
0 before 118.
0 before 118. Because if you only have 3 digits, you got to put a 0 before it. Okay. And now, if you look at this, I want you to tell me, what month was I born? Read this right here. I said the orange.
I have.
June 18th.
I had
Close. It's going to be 0118, which that is January.
January 18th. Sorry.
Yeah. Okay. So you see how I did that, guys? If our number, we put a 0 before it. So you have 0118. It kind of looks like, let me stop sharing for a second. I want to show you what it looks like. This is what it would look like. Can you see me? Oh, right. Yeah, I am. Okay. You guys see this here? How it says 0118? Says 0118. That is representing my birthday. It would be 01, which is January, and then the 18 would be the day I was born. Okay, so January 18th, which is cool. Okay, so even though I know it seems like you're like, oh, well, you knew your birthday to begin with. Of course I did. But the idea is that you'd be able to try this on somebody and figure out their birthday. Okay, so let's try this on somebody. Raise your hand. Do you guys have someone nearby that you can try this on, or no? Or should we do it over Zoom? You guys can guess somebody's birthday. We'll do the trick with somebody.
Wait, hold on.
Your birthday is January 21st.
Oh, you know it already. So maybe I have an idea. I have an idea.
I didn't even
You do it.
Yeah, how about let's do this. Let's make somebody the magician, and let's make
the
somebody
formula?
the, I guess,
I
the
can be the
participant.
magician.
Who wants to be the magician?
I
Who's
do.
that? Who's raising your hand?
I'm-
Emmanuel, you want to be the magician?
Yeah, sure.
All right, you're the magician.
What's the formula?
And who wants to
again?
be Emmanuel's subject or Emmanuel's participant? All right, Calvin, let's go. All right, so here we go, guys. Let's see how this works out. So I'm going to
And
show you
you'll
guys the
never
screen
end
again,
up
so you have the
with a
instructions,
number
and then we're going to go for it. So here we go.
So,
All right, so
Okay.
let's start. Emmanuel is the magician. So Emmanuel, you're going to tell Calvin what to do, okay?
So, okay, Kelvin, I want you to, in your mind,
actually some exceptions with this trick?
Are there exceptions to this trick? No, it's all algebra based. So that you're really not going to have any problems with this trick unless someone like has a birthday that is not even a birthday. You're not really going to experience any problems with it. It's all algebra calculations, which I'll explain a little bit at the end what's going on. But go ahead, Emmanuel. Go ahead and ask Calvin what to do.
okay, so Kelvin, I want you to pick your month that you're born in, and then I want you to multiply it by 5. And
Calvin,
then,
don't tell us what you get. Don't tell us. Keep this secret, okay? Don't tell us. Write it down on your paper and tell them when you're done.
so yeah, so you choose your month, you multiply it by 5, you add 6, then you multiply that by 4.
Here, you know what? Why don't we give Calvin a second just to make sure he can record this. Calvin, did you multiply the month you're born by 5? Are you still working on it?
I multiplied the month I was born by 5, and then I added 6.
Awesome. Okay. Now, go ahead, Emmanuel.
Then you multiply that by 4.
Calvin, tell us when you did that.
I have done that.
Okay.
Then add 9.
Okay, I added 9.
Then multiply that by 5.
Okay,
Then subtract
Add
165.
the day you were born.
Oh, then add the day you were born.
Counting.
Then, oh yeah, you have to do that. Yeah, right.
And then you're gonna tell Emmanuel what number you got. Once you added your, or did you add the day you were born?
yeah, but I don't think it's right because it's like. Okay, just pretend. I'm just gonna write down.
Hey, why don't
I
you do
don't
this?
know if
Can you
it's
send
right.
me the number you had? Send me what your birthday is. I'll tell you if it's right. Send it to me in the chat. You see the chat there? Just send it to
Okay,
me.
I'll send it to you.
All right. And I'll double check it for you. Okay, so here we go now. Let me quick do this calculation here. Ah, how do I go back? All right, give me 1 second. Let me just double check and then we'll keep going. All right. So. Sorry, hold on. Give me 1 second, guys. I promise. Almost done with this. I need my calculator here. Okay. And then, Calvin, do this. Can you send me the number that you got? And I'll tell you what number I got. Let's see if we're on the same page.
Okay.
I'm just gonna.
Yeah, that's the number I got too. So I think that will actually be okay. Yeah, that works totally. So go ahead and tell Emmanuel what number you had.
I got
magic number?
1370. I mean,
1370.
1,370.
All right, Emmanuel, you got that number?
Yeah, 1,370, just checking. And then subtract that by 165. You were born December 5th.
Oh, yes, that's my birthday.
Oh my gosh. Emmanuel is a true math magician. Can you believe that? You got it. That was 100% right. I was kind of worried. I'm like, maybe something's not going to go right. And it went perfectly.
Another math.
Wait, I want to write this down so I can try it on my friends.
Yes.
But I didn't finish it. I only got to step 3.
Let me write here. You can write this down. So have them. So let's go ahead, write down step 1.
9 times 9 is 80.
Or guys, if you want me to, I'll send you instructions after this meeting. I'll send it to your parents' email address, and you can print out the instructions. That might be easier. So you don't have to write it down.
Miss Ava?
Yeah.
In it says where I can see it, it says remaining meeting time.
I
6
see that at
minutes.
6:56. So here's what I'm gonna do, guys. I want to go to questions really quick, and I will send you instructions right after this. I'll send you a copy of the instructions so you guys can look at them, and then you could try it on people. Okay. So that, and then you don't have to write everything down. I'll send you all these instructions. And I always like explaining the experiments. So the reason why this experiment works, guys, is because it's algebra. And what happens is the math is rearranging their information and it makes it really complicated. But in the end, it makes a number, that final number that we get, it actually ends up simplifying it back to their original number. So they're plugging in those numbers when they're doing their calculations, and then we just end up kind of simplifying it back down in the end. So it's cool. It's a cool algebra trick. So I guess that's all I have for you guys. Does anyone have any questions on anything? I want to make sure I hit that up before we stop our meeting. Any questions? Anybody? And I'll send you the magic trick after, so you guys can do it. You could try it on people.
I have something. Can we do it one more time?
You want to do the magic trick one more time? It's 3. Okay, let's see how much time we have. 6 minutes. All right, let's try it one more time. Give me who wants to be a magician? Who wants to be the person, with the birthday?
Can I be the person with the birthday this time?
Who wants to? Who's that?
Please.
Calvin wants to be the magician. And then who's that? Who's Regina Gibbons? I'm sorry, what's your name?
My name is Sean.
Sean. Okay. How about this, Calvin? Because you already got a chance. Let's do Owen and Sean. Okay. So Owen, you want to be, what do you want to be? The magician? Oh, you want to be the person with the birthday. So Sean is going to be the magician. and Owen's going to be the person with the birthday. Okay, let's see how this goes. So I'm going to share my screen one more time, and let's go ahead and give it a try.
We need to.
All right, so let me go back to the instructions. So Sean, as the magician, you're going to ask Owen to do these things, okay? And Owen, if you want to confirm if you have any questions on anything, you can private chat me and I'll help you out. Okay?
Owen, please multiply the month you were born by 5.
Okay. Done it.
Okay.
Step 2, add 6.
Good.
All right.
Step 3, multiply by 4.
All right.
Okay.
Step 4, add 9.
All right.
Step 5, multiply by 5.
All right.
Step 6, add the day you were born.
All right.
And now you are going to tell Sean what your number is.
687.
All right, Sean.
6,
And now it's your turn to do the final calculation.
6, 8, 5.
And remember, if you only have 3 digits, what
Maybe
happens?
20 seconds.
Correct.
Look at that. That was awesome. That was so good, guys. That was perfect. So did you ever think that you could guess somebody's birthday just from numbers and telling them to think of things, and you take the number and you can kind of twist it and get it back to their birthday, which is so fun. So I will do this. I will send this trick to you guys because I know it's a lot of steps. You might not remember all of them. I'll send you guys the trick so you can think about it, and then you can try it on different people. Okay. And ask your friends too, or ask friends and family. All right. Any final questions? Any comments? Anything? No?
No.
No? All right, guys. Then I will see everyone, I think maybe next week or the week after. I might do one next week. So please submit more questions. I always like reading your questions. So please, please, please keep submitting stuff. Anything you think of, submit it. We might do it. You never know. So submit questions and I will send out the magic trick to everybody. All right. Bye. See you guys.
Bye.
See you next week.
Thank you.
Yeah.